Really quick review of yesterday. Yesterday was all about the law of conservation of momentum, right? And remember what the law of conservation of momentum says is that if I have a closed system, so there's no outside forces doing anything, then the total momentum in that system will remain constant. Uh, and we did a whole bunch of problems. We did more problems that dealt with what we would call explosion problems. And in an explosion problem, that's like, not to try to make anything violent or anything, but that would be like a gun and a bullet. Okay. Before the gun and the bullet are fired, the total momentum is zero. After the gun and momentum, or I'm sorry, after the gun and the is fired, the bullet will have a certain amount of momentum going forward. The gun will have a certain amount of momentum going backwards, and those momentums will equal each other, one in the positive direction, one in the negative direction, so that the total momentum will stay zero. And then what we did yesterday is we talked about collisions. So if I have, say, cars hitting each other, right? The total momentum before those two cars hit each other, that is going to have to equal the total momentum after those two cars hit each other. So in this example, I have one car sitting still. I have a truck that hits it. The truck was moving. So the truck transferred some of its momentum into the car. So the truck had less momentum in the end, but the car had more. The total between the two was the same before they hit and after they hit. So let's look at a few more problems that are like these collision problems. Okay. Now, I told you guys yesterday that I personally like to draw pictures when I do these. And part of the reason I like that is because I just think that it makes more sense for most people. So I'm going to draw this one out too. So I have Jim, and Jim has a weight of 600 newtons. All right. Now, we don't want Jim's weight. What we want is we want Jim's mass. Okay. Now, we didn't talk about this before because this year has been kind of a whirlwind so far. But you can write this down with your other equations, you guys. Weight is equal. Oops, if I could spell it right. Weight is equal to mass times gravity. All right. So mass is equal to weight divided by gravity. Now, gravity, can someone either type or just shout out, what is the acceleration of gravity?
9.8.
9.8. Yeah, that's right. So you can always, if I give you the weight, you can always just convert that really quick into the mass by dividing by 9.8. Now, will anybody be upset if I round 9.8 to 10 just to make this math easy?
No.
No, okay. All right. So just so you guys know, in class, that's what I usually start doing. At a certain point, I just start rounding gravity to 10. It just makes things easier for us. And if you want to, on any future tests, especially going into next semester, you could do that if you want. So I have Jim. Okay. And Jim is standing on a skateboard. So there's my skateboard. Okay, Jim has a mass of 60 kilograms then, because it would be 600 divided by 10. Now, it says that the skateboard is stationary. So Jim's velocity, that's going to be 0 meters per second. Okay? Now, Fred is running. So Fred is running towards the skateboard. And Fred has a mass of 80 kilograms. So he's bigger. And he has a velocity of 5 meters per second. Okay? So I have two separate people before this collision. Because what's going to happen is Fred runs and he jumps onto this skateboard. So this is before the collision. And then after the collision, I'm going to have Jim and Fred, both of them, they're going to be both on this skateboard. Okay? I want to know what will their velocity be after he jumps on. Now, what is their mass combined if they're both on the board? When they were separate, it was 80 and 60. So combined, their mass has to be
140.
140. That's right. Thanks. So their mass is going to be 140 here. So basically, what we're going to do is we say, okay, all of this momentum, all of the momentum before the collision happens, that has to equal all of the momentum after the collision happens. All right, now momentum is m times v. So I'm going to take 80 times 5, add 60 times 0. That's going to have to equal 140 times my mystery velocity. Now if I do my arithmetic here, this will be 400 plus 0 equals 140v. You guys know that 0 just goes away, right? 400 plus 0 is just 400. So now I have to say, I want to get rid of this 140. It's being multiplied. So I think you guys know algebra-wise, I'm going to divide it, right? So my answer, these are going to cancel. So my answer would be that, and I'll write it on this. Oh no, you guys can probably see it now. My answer will be V equals 400 divided by 140. Can someone tell me what that is? 2.85. 2.85 meters per second. So does everybody understand how I drew my picture and how I organized the momentums? Does anybody have a question about that? No? You guys seem pretty good? All right. And then just so you guys know, if you wanted to, these little pictures, I mean, I still wrote everything down, right? This would take the place of writing all the variables down in one spot. So this would be the 4 out of 10 points on the test. If all you did was draw these little pictures out, put the numbers by the right things, you get 4 out of 10 points, right? For telling me what you know and then what you're looking for. So let's do another one of these. Okay. I have a 15 kilogram medicine ball. Just in case you guys don't know what that is, they're the exercise balls in the weight room. They're weighted balls. And this medicine ball is traveling at a velocity of 20 meters per second on ice. I don't know why that is, but I'll draw out. I have my medicine ball. It has a mass of 15 kilograms. It has a velocity of 20 meters per second, so it's moving, right? It's moving in this direction. And then there's someone who's just sitting down on the ice, which is strange, but they have a mass of 60 kilograms. And it says that they're at rest. So they're just sitting at rest, so their velocity is 0. Okay? Now, the person catches the ball. So while they're sitting, right, I guess I had them going the wrong way before. So while they're sitting, they catch that ball. That means that the ball is going to be attached to them. All right? So what would be their combined mass again? If it was 60 and 15, I know you guys know this. Okay, yep, it's 75. So their combined mass will be 75 kilograms, and I want to know how fast will that person be going? Now, here's a way to check our answer, you guys. Our answer is going to have to be between 0 and 20. because the ball was moving at 20, but it only had a mass of 15. Well, now the mass increased, so the velocity will have to go down. So it'll have to be less than 20. It'll have to be more than 0, though, because that person has some momentum now. So once again, all of this momentum right here, this momentum plus this momentum, let me write that a little better. That'll be the one nice thing about being back. It's easier to write on the board than the computer. So this momentum plus this momentum is going to equal this momentum, right? So another way of saying that is the momentum before the collision happens has to equal the momentum after the collision happens. So I'll write down all the momentums. It'll be 15 times 20 plus 60 times 0. That has to equal 75 times my mystery velocity. So 15 times 20, you punch that in your calculator. That'll be 300. 60 times 0 is 0. Okay, and 300 plus 0, you guys know, is just 300. So I got to get rid of this 75 again. It's being multiplied, so I'm going to have to divide it. So I'll have to divide both sides by 75. Now this is going to cancel. Oops. That's the wrong thing. So that's going to cancel. And I'll end up with V equals 300 divided by 75. And I can do that math in my head, but you should check my math on your calculator. The velocity will end up being 4 meters per second. So you guys, when you read these problems, once again, I told you that one of my main goals for you in this class was to become better technical readers and better problem solvers, right? Those are like two of the big things I want you to learn to do better. The reading of the problem, that's really kind of the hardest part. Reading it and making sure you just have to separate mass and velocity for each object before they collide, and the mass and velocity for each object after they collide. All right, so let's, any questions on that one? Do you have anything that you need to know about that problem? No questions. All right, we're going to do another one. Today is just all about doing problems. So in this problem, you guys, I have a minivan, and it stopped at a stoplight. So that's a bad version of a minivan, but that's my minivan. All right. Okay. So my minivan has a mass of 3,000 kilograms. It says that it stopped at a stoplight, so it has a velocity of 0. Now I have a Honda Civic, so that's not a very big car. It's kind of small. My Civic is also very funky looking. All right. But this Civic has a mass of 1,500 kilograms, and it has a velocity of 15 meters per second. Okay. Now the person in the Civic isn't paying attention, so they hit the minivan, runs into the minivan, and it says that their bumpers lock. Well, if their bumpers lock, then I'm going to have two cars, kind of two mangled cars, stuck together, right? And their masses will combine once again. So if one is 1,500 and one is 3,000, the new mass here will be 4,500. And I want to know how fast will they be moving when they collide. So this is really similar to the person who caught a medicine ball. I start out with two masses, end up with one. So once again, all of the momentum before something happens has to equal all of the momentum after something happens. So I take all the m plus v's before it happens, add them up. and set that equal to all the m plus v's after it happens. So I have 1,500 times 15 plus 3,000 times 0. That is going to equal 4,500 times v. Okay, and can someone tell me what 1,500 times 15 is? I should be able to do that in my head, but yeah. So I got 22,500. And 3,000 times 0, that's 0. And that equals 4,500 times v. Now, once again, we got to get rid of that 4,500. So we're going to divide both sides by it. Those are going to cancel. And I'll have to write this on the side. Didn't leave myself enough room. So the velocity is going to be 22,500 divided by 4,500. When I put that in my calculator, I get 5. Can someone confirm for me that that's right? Okay. So any questions on this problem now? No. All right. So let's go on to the next one. Now, for this problem, you guys, I want you to try to do it on your own. So I'm going to give everyone 5 minutes. And then at the end of that 5 minutes, I'm going to, we'll go through it, but I'm going to solicit answers from random people on my list. Okay? So try to do this problem on your own.